Welcome to this new series of practice questions for the CWI Fundamentals Examination, also known as CWI Exam Part A. I will be discussing CWI Fundamentals questions and explaining the rationale of all the choices, even the wrong ones, so that when you take the exam, you will have the mindset and the right concepts equipped, giving you a high chance of passing the CWI exam. Without further ado, let's get started. This is the solidified layer formed during stick welding and must be removed. Letter A, tungsten. Letter B, porosity. Letter C, slag. Letter D, arc strike. So tungsten does not pertain to stick welding because the welding electrodes of stick welding does not contain tungsten. Letter B, porosity, is a weld defect that is the entrance or the entry of hydrogen molecules to the weld, producing that weld defect called porosity. Letter D, arc strike, is also another weld defect or discontinuity that unintentional or intentional striking of the welding electrode to the other part of the base metal at or near the welded portion of the metal. So that leaves us to the answer, letter C, slag. Slag is the solidified layer formed during the SMAW process, enabling the molten weld pool of metal to be cooled and also to be shielded from the harmful effects of atmospheric gases. Next question. What are the specific functions of the electrode coating performed during welding? Letter A, provides a gas stream to shield the molten weld pool from atmospheric oxygen, hydrogen, and nitrogen contamination until it solidifies. Supplies the oxidizers and fluxing agents to clean the weld. Adds alloying materials to the weld pool, enhancing its properties. Letter D, all of the above. Basically, letter A refers to us as the shielding property of the electrode of stick welding. Letter B refers to us as the deoxidation process of the electrode. And letter C is basically the alloying characteristic of the electrode, basically adding the materials to the weld pool, enhancing its mechanical properties. All of these properties or these characteristics are a function of the electrode coating performed during welding, and thus the answer is letter D, all of the above. Next question. What type of electrode fits the following description? Tensile strength of 60,000 psi, suitable for all position, and has low hydrogen electrode. Letter A, 6010. Letter B, E7018. Letter C, E6013. Letter D, E6018. So letter A, E6010, is an electrode with 60,000 psi, so that might be the correct answer. Number 1 is suitable for all positions, so that might be a correct answer. But the last digit, so what does it refer to? So it's a chemical composition for that specific welding electrode. But is it a low hydrogen electrode? So for letter B, so you can automatically cancel that out because 70 pertains to as 70,000 psi strength for that welding electrode. E6013 might be the correct answer, but what does number 3 meant for that last digit? Letter D, E6018. So that is the correct answer because the last digit 8 refers to us as the low hydrogen electrode. Normally for low hydrogen electrodes, the last digit for SMAW ends with 5, 6, or 8. So that denotes a low hydrogen electrode. Next question. What problem does moisture entering the electrode coating cause in SMAW? Letter A, electrode temperature change. Letter B, short circuits the electrode. Letter C, introduce hydrogen to the weld causing brittleness. Letter D, none of the above. So when moisture enters the electrode coating, so what does it cause during the stick welding process? So does it change the electrode temperature? Does it short circuit the electrode? short circuiting mainly focuses or mainly pertains to GMAW processes. So letter C is the correct answer, because when moisture enters the electrode, so basically it's H2O, when it breaks down, hydrogen can cause brittleness to that electrode coating or that molten weld pool in the welding process. So last question. What are the elements of the AWS identification system for SMAW? Letter A, the first 2 or 3 numbers refers to the minimum tensile strength. Letter B, the next number, second to the last number, refers to the position. Letter C, last number describes other characteristics by the coating present on the electrode. Letter D, all of the above. So if you can check the choices, the first 2 or 3 numbers indeed indicate the minimum tensile strength of the weld. The next number to that refers to the position, either 1 or 0. The last number is the chemical composition or any other characteristic that describes that electrode. So all of these 3 choices are accurate, so the answer here is letter D. This welding process is characterized by a solid wire electrode which is fed continuously through a welding gun, commonly known as MIG welding. Letter A, FCAW. Letter B, SAW. Letter C, GMAW. Letter D, GTAW. So FCAW is characterized by a tubular electrode. So definitely that's not the answer. SAW is the submerged arc welding, which is an automatic welding process. GTAW is a welding process which consists of a filler metal or a filler rod with a tungsten electrode to heat and weld the metal. So that leaves us to the answer, letter C, GMAW. GMAW is a process wherein a continuously fed solid wire is produced or is continuously fed through the welding machine or the welding gun, thus affecting or reducing or improving the productivity of the welder and its process. Next question. This mode of GMAW metal transfer characterized by low average current and by pulsing of the welding current. So the GMAW process has 3 main mode of metal transfer. So what are those? So you need to also identify that because it's a common question in the CWI exam. Letter A, globular transfer. Letter B, short circuiting transfer. Letter C, pulse spray. Letter D, none of the above. So from these choices or from the question itself, so it indicates pulsing and low average current. So the answer here is fairly obvious, pulse spray. Letter C. Next question. This mode of GMAW transfer is utilized for small diameter electrodes and sheet metal welding due to its low amount of heat. This mode provides low penetration if used with argon and carbon dioxide mixtures. Letter A, pulse. Letter B, globular. Letter C, short circuiting. Letter D, none of the above. So when welding sheet metal using GMAW, you only need a low amount of heat and low amount of current to basically, because it's a sheet metal, so it's very thin. You don't need large amounts of heat to basically fuse them. So the answer here is letter C, short circuiting, because short circuiting has a low amount of heat and a low penetration with its low current setting, and it's pulsing short circuit input to the weld. So globular is not the answer because it's a form of globules that is inputted to the molten weld pool. So when you use globular in sheet metal, so basically that will melt the sheet metal in itself because of the droplets. Next question. In this mode of GMAW transfer, the low arc voltage is used to minimize spatter and enable deeper penetration. Rate of transfer range from 20 to 70 droplets per second. Letter A, pulsed. Letter B, globular. Letter C, short circuiting. Letter D, none of the above. So the choices here, or the answer here, is fairly obvious as well because of the keyword here, droplets. So the rate of transfer range from 20 to 70 droplets per second, and it enables deeper penetration. So here, letter A, pulsed, and C, short circuiting, because it operates at a lower heat and current setting, it will not be able to provide deeper penetration of the weld. So the answer here is globular transfer, because of the amount of globules that will be produced to the weld pool, so it will enable deeper penetration. Last question. What are the elements of a GMAW electrode? Letter A, ER denotes that the material can be used as electrode or welding rod. Letter B, the third to fourth or fifth digit indicates tensile strength. Letter C, final number is the chemical composition. Letter D, all of the above. So all of this characteristic of a GMAW electrode is accurate in terms of these choices. So the ER denotes that the material can be used as electrode or welding rod. So the next digits indicate tensile strength. So if it can be 70 or 100, so that indicates 70 KSI or 100 KSI respectively. And the final number, as similar to the SMAW electrode, is the chemical composition of that GMAW electrode. So the answer here is letter D. All of the choices are accurate in terms of the elements of a GMAW electrode. So normally the naming of electrodes, the electrode designations are common in the CWI exam. So you have to be familiar with those questions and in the naming of these electrodes. This process is similar to GMAW except that the electrode is tubular and contains a granular flux instead of a solid wire. So in this process, meaning similar to GMAW, is because that the wire is continuously fed as well to the welding gun. But except here, the electrode is tubular, not a solid wire, in the case of GMAW. Letter A, FCAW. Letter B, GMAW. Letter C, GTAW. Letter D, SMAW. So you can immediately cancel out GMAW here. So GTAW is gas tungsten arc welding. So it's not the correct answer because it consists of a tungsten electrode with a failure rod. SMAW is not a continuous welding process or a continuously feeding electrode process, so that's not the correct answer. So the answer here is FCAW. So FCAW is characterized with a tubular electrode that is continuously fed to a welding gun, similar to GMAW. Next question. FCAW electrode identification system is written as EXXT-X. What does T mean? Letter A, tensile strength. Letter B, tungsten. Letter C, transfer. Letter D, tubular. So when you're talking about FCAW, so it is a tubular electrode. So definitely, the letter T means tubular. So the answer here is letter D. So tensile strength, it refers to the first two digits or first 2 to 3 digits of this FCAW electrode identification system. So tungsten does not refer to FCAW, it refers to GTAW. So transfer, or the mode of transfer here, does not refer to FCAW but to GMAW. So you need to distinguish them. So for FCAW, when you see that T in that electrode identification system, that means tubular. Next, some electrodes are designed to provide all of the necessary shielding from the internal flux. What do you call this characteristic? Letter A, shielding gas. Letter B, gas shielded. Letter C, self-shielding. Letter D, both A and B. So for GMAW and FCAW, sometimes you need a separate shielding gas input to protect the weld from atmospheric gases. So for FCAW, one advantage of it is that it can be self-shielding. So meaning self-shielding is that the necessary shielding for the welding process comes from the internal flux. So in the tubular part of that electrode, it has that internal flux inside that tubular electrode, which produces that self-shielding characteristics. Basically the shielding gas or smoke around the weld pool, similar to SMAW. So the answer here is letter C, self-shielding. For this question, an electrode is tagged as E70T-7. What does the second digit mean? Letter A, tensile strength of 7 KSI. Letter B, tensile strength of 70 KSI. Letter C, chemical composition. Letter D, all position. So here, that digit, the number 7 here denotes a tensile strength of 70 KSI, not 7 KSI. Because the number 0, that 0 here refers to as the position for this electrode. So the answer here is letter B. So don't be confused with the tagging for FCAW, as it is slightly different for the naming of GMAW and SMAW electrodes. I have a video for the SMAW electrode naming that you can also see in this playlist or in this channel. An electrode is tagged as E70T-13. What does the last digit mean? Letter A, usability designator. Letter B, shielding gas designator. Letter C, position designator. Letter D, none of the above. So the usability designator is the second to the last digit here. So that's number 1. The position designator is the number 0 after the first digit, number 7. So the answer here will be shielding gas designator. So the last digit for a FCAW electrode designation is the shielding gas. So how can you know that is FCAW electrode? Is by looking for the letter T for the electrode classification system or electrode naming. So if you see here, that means tubular. So for tubular, that pertains to FCAW process.
This welding process makes use of pure or alloy tungsten with the ability to withstand very high temperatures. The electrode is not meant to be consumed. A. SMAW, B. FCAW, C. GMAW, D. GTAW. Now this welding process talks about making use of a pure alloy tungsten that is subjected to a very high temperature. So letter A, SMAW, is known as stick welding, so it uses a consumable electrode. So that does not match what is being asked in the question. FCAW is made up of a tubular electrode, so there's no tungsten in there. GMAW consists of a meters and meters of wire that is being fed to the gun, and it doesn't have tungsten in it. So GTAW, or gas tungsten arc welding, makes use of alloy tungsten that is subjected to a very high temperature, and it is fused with a filler metal or a filler rod that is being fused to the base metal as to weld it in place. So the answer here is GTAW, or gas tungsten arc welding, or commonly known as TIG welding. Next question. What will be the setting of the welding machine for GTAW if the welder intends to hit the base metal more? Letter A, AC. Letter B, DCEN, or DC electrode negative. Letter C, DCEP, or DC electrode positive. Or D, none of the above. So welding machine commonly has the what we call as electronegative flow. right? So it flows to a circuit in an electric or an electrode negative flow manner. So for letter A, AC, so if it is AC, it will not heat the base metal more because of its sinusoidal kind of curve. If you plot it on a if you plot the current, so basically the electrode is not in contact, or it seems like it's not in contact with the metal for a very long period, or much more like SMAW. You can use AC because basically when you can run out of the electrode, you basically take out the contact of that filler metal to the base metal. So it is okay to use AC for that. Letter C, DCEP, heats the base metal more for SMAW because of the electronegative flow. Basically, the base metal will be heated up more because of that kind of circuitry or circuit flow. So the answer here is letter B, DCEN. So for GTAW, one thing you can remember in the CWI exam is it is some sort of opposite the electronegative flow or the flow of the current from SMAW, which is DCEP, if you want to heat the base metal more. So basically, if you want to heat the electrode more, you need to have DCEP for GTAW. So it's kind of opposite philosophies for GTAW and SMAW in terms of the electrical characteristics of the two process. So something to remember. Next question. What is the color designation of pure tungsten electrode classification for GTAW? Letter A, yellow. Letter B, orange. Letter C, green. Letter D, red. So there's no way around this question but to memorize the different electrode classification for GTAW or the designation for the electrode classification for gas tungsten arc welding. So for pure tungsten, the color designation of it is letter C, green. So something to remember, as this is a common question in the CWI exam. Next question. What will be the setting of the welding machine for GTAW if the welder intends to heat the electrode more? So this question was kind of preempted when I asked the previous question. So letter A, AC. Letter B, DCEN. Letter C, DCEP. And letter D, none of the above. So here, as I've said earlier, if you want to heat the electrode more for GTAW, you will have to use DCEP. So it's kind of opposite with SMAW. When you want to heat the electrode more, you will use DCEN. And if you want to heat the base metal more for SMAW, you need to have DCEP. So reverse for you will also need to remember that the DCEN is known as straight polarity, while DCEP is known as reverse polarity. So kind of have you might want to know those nomenclatures for the electrode characteristic or the electrical polarity of the welding processes, because it might not the questions might not ask or might not have the choices as DCEN or DCEP. They might say it as straight polarity or reverse polarity. I might have mix it up, but you can basically search it up if you want to confirm the equivalency of DCEN if it is straight polarity or reverse polarity, something like that. So you can do your due diligence as well. So next question. What is the most inherent welding discontinuity in GTAW that is totally confined within this welding process? So letter A, tungsten inclusion. Letter B, arc stripe. Letter C, porosity. Letter D, none of the above. So the question that is being asked here is, what is a welding discontinuity that is totally confined or totally exclusive with GTAW? So if you are familiar with the process, even if you're not that familiar with the discontinuities or the defects that comes around typically with this process, you will know from the name itself, GTAW or gas tungsten arc welding, because of the electrode consisting of tungsten. You would know that it is exclusive with GTAW, that tungsten inclusion is exclusive to that process, because no other processes or welding processes have tungsten in it. So as you can see here, the welding gun for the GTAW, you can see here the non-consumable tungsten electrode. So GTAW has that in its process. That's why tungsten inclusion has, or it is exclusively a discontinuity within this process. So that's one of the reasons I think AWSD 1.1 does not automatically pre-qualify GTAW because of this discontinuity. No. So basically there are processes that can be automatically pre-qualified without qualifying in a PQR. So GTAW is one of those processes that cannot be automatically pre-qualified. You need to abide by the qualification process of clause 4 of AWSD 1.1. This welding process is characterized by a continuously fed solid wire electrode which provides an arc totally covered by a layer of granular flux. So the question basically is asking what is a welding process that involves a continuously fed solid wire electrode, and as soon as the solid wire is in contact with the base metal, an arc is formed together with a layer of a granular flux. So letter A, SMAW, B, GMAW, C, GTAW, D, SAW. So letter A, SMAW or SMAW, does not involve a layer of granular flux. So basically the flux is being processed through that smoke coming out of the electrode coating of the electrode, from the coating of that electrode, from that stick electrode of SMAW. So that flux is being so to speak burned and protects the weld pool from the atmospheric gases. So that's not the answer here. So we have basically a flux here, or a layer of a granular flux. It's like a sand basically. So GMAW, while it has a continuously fed solid wire, doesn't have a granular flux. Letter C, GTAW, does not have a continuously fed solid wire. It has a tungsten electrode with filler metals that you have to basically fuse to the base metal. So letter D, SAW or submerged arc welding, that's why it's the term is submerged, because the arc is submerged in a layer of granular flux, and it is a continuously fed solid wire electrode through that machine. Basically it can be considered as an automatic or a semi-automatic process because of its continuous wire feeding and a controlled travel speed. Basically the machine you can control the machine's travel speed automatically, unlike for SMAW, GMAW, and other process where the travel speed is being controlled by the welder itself. So a welder here is not needed, but an operator, basically to set up the machine to basically set the speed of the wire feeding and the travel speed of the solid wire. The flux here is automatically being consumed by forming a layer into the weld. So the answer here is letter D, SAW or submerged arc welding. Next question, which of the following is the limitation of SAW? Letter A, can only be done in vertical position. Letter B, a manual welding process. Letter C, weld deposition in small amounts. Letter D, can only be done in position where flux can be supported in the weld joint, normal in flat or horizontal positions. So here in SAW, the one thing that its limitation is it cannot, I repeat it cannot be done in vertical position. So letter A, it's automatically eliminated. So letter B, a manual welding process. So as I've alluded earlier, it can be considered as a semi-automatic or an automatic process because you can control the wire feeding and the travel speed. So letter B is not correct. It's not a limitation because it's an automatic process. So letter C, weld deposition in small amounts. Because submerged arc welding can be an automatic process, and because of its continuous wire feeding and basically have a big machine there, it is known for depositing large amounts of weld pool or weld metal in the base metal. So that's not a limitation of SAW. So as you can basically understand from now, is letter D is the answer because it can only be done in position where flux can be supported in the weld joint, normally in flat or in horizontal position. So you can just imagine, so the answer here is letter D. So you can just imagine if the welding machine is put in a vertical position, so the flux will fall because it cannot be supported in the weld joint. Because of gravity, it will just keep falling down. So if you can imagine, a flux is like a sand covering the weld. So its primary purpose is to prevent moisture from creeping into the weld, much like the electrodes needed to be stored in the oven. So basically, this flux also has a proper storage procedure to be followed as well. So basically here, the limitation basically of SAW or SAW is that the machine must be configured or must be configured in such a way that the flux will not fall to the ground, because if it is contaminated, you cannot use it. So it will just be wasted. Which of the following is false regarding granular flux for submerged arc welding? Letter A, flux is placed into a hopper above the welding torch and fed by gravity. Letter B, flux is forced to the gun using compressed air. C, flux when properly stored can cause moisture from creeping into the weld. Letter D, flux may prevent the welder from seeing the arc with respect to the joint. So let's run through the choices here. So flux is placed into a hopper above the welding torch and fed by gravity. So this is correct. This is true because the flux is basically fed into the hopper above the welding gun, and as it falls through the hopper, it falls down to the weld arc itself, or the base metal to be joined. So it just falls through gravity by the hopper. So the flux is forced to the gun using compressed air, so that is true as well. So it is for it to be loaded into the welding gun, the machine uses compressed air. So since the flux is a granular or is a solid, it is made up of solid sand, or it is made up of basically like sand, it may prevent the welder from seeing the arc because from the term itself, submerged arc, the arc is submerged through this granular flux. So letter D is also true. That might be an issue with the welding operator. He might not see the arc. One thing that you can remember, or one safety precaution that you may bypass in SAW, is that you may not use welding helmet or goggles, because you can just use goggles because the granular flux might go through your eyes, but the normal welding helmet to prevent you from seeing the flash, because basically flash in SAW is non-existent because the flux is covering the arc. So that's something to remember as well. So the answer here is letter C, or I'm sorry, the answer here is letter C, not D. So that's a typo. So flux for SAW is like a sand covering the weld. So its primary purpose here is to prevent moisture from creeping into the weld. So as I've alluded to in the previous question, so the flux needed a proper storage procedure, much like the electrodes needing to be stored in an oven. So not to contaminate the flux. So if it is properly stored, it can function properly as to not let moisture creep into the weld. So it must be stored properly to preserve its function. So to prevent the weld from atmospheric attacks, basically from hydrogen, oxygen, and all those kind of stuff. So the answer here is letter C, not D. Which of the following is the advantage of submerged arc welding? Letter A, high deposition rates. Letter B, non-existence of slag. Letter C, flux promotes accumulation of moisture in the weld. Letter D, none of the above. So basically, flux is a sand. It's basically slag itself. No? So letter B is not the answer. So basically, you have slag in it. But you can just remove it easily because it just covers the weld arc. It doesn't stick basically on the weld, unlike unlike stick welding. So flux promotes accumulation of moisture, so that cannot be further from the truth. Flux basically prevents moisture into the weld, so that's why it's covering it. But the one advantage of submerged arc welding is high deposition rates. If you want high deposition, you want to fill that metal in with, if it's very thick, like a 20-inch or even 60-inch metals. I've seen some factories that weld steel plates almost, I think 1.5 to 2.5 inch thick. Basically it is a submerged arc welding. So basically it can produce high deposition rates of weld. So the answer here is letter A, high deposition rates. Remember that if you want to deposit or if you want high deposition rates, use SAW any day of the week. It will produce your desired weldment into a thicker metal. So next question here, F7A6-EM12K is a SAW electrode or a SAW electrode. What does F and the digit 7 mean? So letter A, iron, 70,000 psi strength. B, flux, 7,000 psi strength. C, flux, 70,000 psi strength. D, iron, 70,000 psi strength. So for the nomenclature of the SAW electrode, so F means flux. So for SAW, flux is included in the designation. The digit 7 here is 70,000 psi strength or 70 ksi. So I might do a video regarding this, discussing the SAW electrodes and its nomenclature. So the answer here is, of course, letter C, flux, with 70,000 psi strength. Who does a welding inspector talk to primarily if there is a case of multiple rejects in a weld by a welder? This personnel is present especially for big construction projects. So I basically have this experience wherein there is a multiple rejects produced by a welder, and as an inspector, as an engineer, who did I talk to address those issues? So A, welder. B, the welding engineer. C, welding foreman. D, the design engineer. So basically, if you direct your communication or you confront the welder, so maybe it may ensue a confrontation between you and the welder, because typically for big construction projects, it has a tight schedule. So the pressure might be on the welder to produce multiple welds at that tight deadline or tight schedule. So it might not be a good idea to confront him directly if it has multiple rejects or he produced a multiple rejected welds. So letter B, welding engineer, basically is not responsible for this because he created the welding specification. So he will not be the one the welding inspector needed to talk to in this situation.
letter C, the welding foreman, is a good answer because the welding foreman basically he's the reporting supervisor for the welder. Basically, he has the rapport and the empathy to talk to the welder in case of multiple rejects and explain to him how he can rectify those defects. So letter D, the design engineer. The design engineer, he's responsible for creating the specification or the drawing that is needed to be implemented during construction, or the one that is referenced by the welder in terms of welding the structures or the components, basically to build it. So the answer here is the welding foreman. The foreman can communicate directly with the welder for the defects without a confrontation. So next question is, this is known to be the best quality for a welding inspector. A, maintenance of inspection records. B, good physical condition. C, professional attitude. D, experience. So basically, all of these qualities of a welding inspector is good. So what is the best amongst all of them? So letter A, maintenance of inspection records. Basically, some proponents or some owners of the plant, for example, needed the inspection records for reference in the future. So if there is a similar defect that occur in the plant, they may refer to that inspection record. So it is important for the welding inspector to maintain those inspection records in good condition, so it can be referenced in the future, and it can be a good reference for those similar conditions that will happen. Good physical condition. Basically, the welding inspector needs to be in good physical condition for him to go to tight areas, confined spaces, hard to reach areas, or areas with at high elevation, basically. So he needs to be in good condition for that. See, professional attitude. So this just the quality of a welding inspector to provide unbiased opinions based on facts, make his decisions based on facts, and to continuously learn throughout his tenure as a welding inspector. The experience basically enables the welding inspector to become more efficient in his work activities. Basically, he can streamline those activities and become more efficient of providing judgment in terms of whether to pass the weld or not. And basically, because of his experience, he has a knowledge of good knowledge, good reference knowledge of what or how he can pass those or reject those weld that he inspected. The answer here is letter C. So this enables professional attitude. This enables the welding inspector to conduct himself properly in the workplace and to continuously learn. By the way, so you can pause the question if pause the video at any time if you need to think of the answers prior to me explaining the rationale of each of the choices. So you can do that. So what do you call a body of law which, if used in a job specification or contract, can be exerted with the full legal authority of the law? A, code. B, standard. C, specification. D, all of the above. So basically, a standard is a reference document in which the specification of an equipment, or in this case a weld, is basically compared to if it complies with the acceptance criteria. The specification is just a list of parameters, on it, not to go on a tangent, but the welding procedure specification is the best example for a specification because it lists the needed specs for the weld. For example, the electrical current, the base metal, the filler metal, and the technique for the welding as well. So the answer here is A, code. So for example, if AWSD 1.1, which is a code for structural welding of structural steel, is used and is called upon in the contract or job specification if accidents happen or lapses are made during construction of that project or that maintenance activity, and is found that there are non-compliance with the code. The engineer on record or the ones responsible for it may be called upon or subpoenaed in a court of law to basically be questioned regarding his compliance or lack thereof of compliance with regards to the code that's supposed to be used in that contract. Next question. Which of the following is not a standard used in the CWI examination Part C? So the Part C of the CWI exam is basically an open book where the examiner must choose in the following standards or in a set of standards. So basically, he doesn't need to be just inspecting that code or standard when he passed the exam. He basically can do it, but in the CWI exam, you need to choose just one. So, which of the following in this question is basically what you can choose? So, A. AWSD 1.1, B. API 1104, C. ASME 9, D. API 610. So, AWSD 1.1, as I've talked about earlier, is the structural code for steel. API 1104 is the welding of pipeline and related facilities. ASME 9 is welding and brazing procedure qualifications. But basically, AWSD 1.1 also has a pre-qualification of welding procedure specification. And letter D, API 610, is for centrifugal pumps for petroleum and petrochemical industries. So the answer here is letter D, API 610. This for centrifugal pumps used in petroleum and petrochemical industries. This is not used as a standard in the open book part of the CWI exam. Okay, so last question for the day. So, the welding inspector is considered to be blank of the welding engineer in the field. So, letter A, right hand, B, assistant, C, lead, D, eyes. So basically, this what happens between how you can inspect the quality of the weld. So there's what you call a quality assurance and a quality control. Basically, the one responsible for the quality assurance, meaning the creation of specifications, the quality standards, is the welding engineer. So basically, does that and implements that in a construction project or in a maintenance activity in the plant, for example. So the welding inspector is in charge of the quality control, meaning he validates if those weld is complying to the welding or quality standards that the welding engineer produces or implemented. So from that idea, you can basically have a deduction of what is the right answer here. So letter D, eyes. So the welding inspector is in charge of the quality control of the specifications created by the welding engineer, hence the eyes. Which of the following is not a function of a welding inspector? A, prepares inspection procedure. B, qualify or certify welders. C, auditing of vendor providing services but not the materials. D, ensures conformance with the codes, standards, and specifications. So basically, these are the functions of a welding inspector. So A, the welding inspector prepares inspection procedure. So he documents how he will go about inspecting the weld during the activity. So during the welding activity, so he can impose an inspection points where he can witness the welding activity and provide what tests will be done for the welds, so to ensure the quality and for him to make a decision whether to pass or fail the welds. Qualify or certify welders. So there's a document called the welder's qualification test. So the welding inspector also provides qualification and certification for the welders for a specific type of welding activity. or for a certain position and for a certain material. Basically, that document outlines that. Letter C, auditing of vendor providing services but not the materials. So for example, when a refinery is in a shutdown or a plant is in shutdown, so the welding inspector may be instructed to audit the vendor providing the services, but the last phrase is not good, because he's also in charge of providing audit or inputs to the base metal or the materials that will be used in welding. The documents like MTRs, mill certificates, the factory standards that is used for the base metal, the production of the base metal, the testing or the destructive testing used prior shipment is also should be analyzed and scrutinized by the welding inspector. So letter D, ensures conformance with the codes and standards and specifications. So this is part of the basic function of a welding inspector. He needs to ensure that the weld quality, the base metals, and other aspects of the welding activity is in conformance with the codes, standards, and applicable specifications. So the answer here is letter C. So the welding inspector needs to also check the material specification that will be used in welding. Basically the base metal, not just the filler metals and the weld quality itself. It needs to be a holistic approach. Yeah, the inspector is also responsible for the quality of the base metal, as this can lead to failure if not checked. So basically, if you check the weld but you didn't check the base metal, so it will result to a failure eventually. Next question. If the inspected weld is found to be an IJP or incomplete joint penetration, what should the welding inspector do first? So this is basically a situational question. Reject the weld as it has incomplete penetration. B, pass the decision to the NDT specialist. C, clarify the drawing and consult with the design engineer. D, ask the welder to completely fill the weld joint. So basically, this is part of the communication that the welding inspector needs to conduct during his day-to-day activity. Basically, here is letter A. It states that you need to reject the weld as it has incomplete penetration. So basically, if some welding procedure or some specification or drawings may not accept incomplete penetration, so that can be an answer. Letter B, pass the decision to the NDT specialist. So not quite. So basically the choice here is vague. So you may not need to pass the decision to an NDT specialist here. So it needs not to be specific to a non-destructive testing specialist. So it's just incomplete joint penetration. Basically, you can see the discontinuity or the defect just by looking at it. So the NDT specialist might not be the one, or he may not be the the one that needs to be consulted immediately. So letter C, clarify the drawing and consult with the design engineer. So basically, some specification or drawing specifies if the structure or the components to be welded are just incomplete joint penetration. So it may be acceptable for some drawing or design documents. So you may need to consult your design engineer for this one. Ask the welder to completely fill the joint. So from my point earlier, so you need to consult the designer of the structure or the components if it is indeed an incomplete joint penetration. So the answer here is clarify first the drawing and consult with the design engineer. So you need to be in consultation first with the appropriate personnel that design the joints or structures. Next question. The term used to delay a production or construction schedule to allow inspection of a component or components of the work. So basically, this term is indicated in the inspection test plan. So letter A, pre-construction. B, inspection point. C, witness. D, hold point.
So letter A doesn't make any sense. Basically, pre-construction doesn't align with what the question is asking for. Inspection point is a more general term for this one. Witness is one of the points that is indicated in the inspection test plan. The hold point, basically this is the answer. It delays the production or construction schedule to allow inspection of a component. So what's the impact of a hold point? No? The hold point is if the inspection did not yielded a positive outcome, the succeeding work activities related to that activity will not be able to start unless the test yielded a positive result. For example, the welding inspector may need to inspect first the weld joint preparation done by the fitters or the welder itself before proceeding with the root pass, the hot pass, etc. So he may ask or indicate in the inspection procedure or the test plan that the inspection for the joint preparation is a hold point. Thus, if he founds it unsatisfactory, the welder needs to rectify the joint preparation to the acceptance criteria so as to proceed with the succeeding activity, basically to weld the joint. Next question. Which of the following is not a good practice for maintaining an inspection record? Signing the inspection record, indicate the job name, location, and specific test information, ink or typewritten, basically the inspection record needs to be in ink or it is typewritten by a computer. The errors are single lined out. So letter A, so the welding inspector or the one that created the inspection record needs to sign the inspection record. So he needs to be accountable for it, basically by signing his name. Indicates the job name, location, and specific test information. So it is essential that the inspection record has a corresponding job activity where the location may be. For example, if it is a plant where the specific location, the activity is conducted in that plant, in the production area, for example, and the specifics of the testing that is done. So what is the acceptance criteria, what tests, procedures are done, etc. And it needs to be in ink or typewritten. For errors must be single lined out, and what is missing in this choice, it needs to be initialed. So if errors are made during the remarks or indication of remarks in the inspection records, it must be single lined out and initialed by the one who did it. Basically, it is the welding inspector that made those remarks. So if he has errors on it, he needs to be initialed as well. Last question. So NDT personnel other than CWIs are typically certified to what document? Letter A, AWS QC1, B, AWS D1.1, C, API 1104, D, ASNT SNT TC1A. So the answer here is letter D, ASNT, which stands for American Society for Non-Destructive Testing. Basically, these certifying body provides certification for NDT professional. The most important part of an effective safety program is compliance of personnel, B, protective equipment, C, management support, D, safety rules. So in order for a safety program to be effective, what do we need basically? So what is the most important aspect of it? So letter A, compliance of personnel. So compliance of personnel is needed basically for an effective safety program to be conducted, but it's just one piece of the puzzle basically, but it's not the most important part. Protective equipment is also important, but in terms of, if you remember the hierarchy of a safety program, so basically the first one is elimination of hazards, substitution, engineering and administrative controls, and the last one is PPE, right? Because it is the last line of protection for the personnel against any hazards. So basically it is important, but basically it is in the last part of that hierarchy. Letter C, management support. So like any other programs
maybe it's safety, quality, etc. So the management support is important for everyone's buy-in and compliance for an effective safety program. Safety rules is basically what entails that safety program. So the rules and regulations and the program itself, or what consists of the program itself for that safety program. So the answer here is letter C. So management support. So unlike any organizational program, management support is needed to have for everyone's buy-in and compliance with the safety program. It needs to start from the top, basically. Next question. This is a type of permit used for welding, cutting, or similar activity is done to areas not normally assigned for such operations for the purpose of alerting the area supervisors. So letter A, cold work permit, B, hot work permit, C, vessel entry permit, D, no permit is needed. So for the first choice, so cold work permit, it is just for a work activity that doesn't produce sparks or doesn't generate any heat. So that's cold work. Hot work is for welding, cutting, that use oxyacetylene for that example. Basically the one that generates fumes or generates heat for that activity. For refineries, for plants that is normally not designed for any welding activity or any hot work activity, hot work permit is needed to alert the area supervisor of any activities that will generate heat, that will be a hazard to the plant because it might ignite the fumes. For example, in an oil and gas refinery or a petrochemical refinery, petrochemical plant that normally generates a fumes. So these hot spatter or generated heat might ignite those, basically creating fire. So vessel entry permit, this is used for confined spaces that needs to be validated first of its oxygen level before any activity is conducted or commenced. No permit is needed. So basically it is dangerous if we do not have any oversight for what mitigations or precautions the welders or the supervising personnel is doing for that hot work activity or for that welding or cutting activity as stated in this question. So the answer here is letter B. So it alerts the area supervisors of the areas in which hot work activities are going on, enabling him to prioritize the firefighting resources if needed be. So for example, mitigations are in place, everything is fire extinguishers, but basically it was not enough. The fire generated just spread throughout the area. So if you have a hot work permit, basically it alerts the supervisors to prioritize those firefighting resources, the hydrants, the hoses, the fire trucks to that area. Which of the following is not considered a shielding gas? So shielding gas basically protects the weld from atmospheric gases, basically from embrittlement and contamination of hydrogen. Basically a shielding gas enables the quality of the weld from being contaminated by those gases. So in this question, what is not considered a shielding gas? Argon, helium, carbon dioxide, carbon monoxide. So one of the basic traits of a shielding gas, it needs to be inert. So argon, helium, carbon dioxide are normally used as shielding gas for a lot of processes, basically for GMAW, GTAW. For SMAW, it also has a shielding gas which is generated from its flux or coating, electrode coating. So the answer here is carbon monoxide. So it is emitted as one of the harmful fumes or gases during welding, but it is not considered as a shielding gas. Next question. What is the reason why compressed gas cylinders are returned when there is still 25 psi of contents remaining? So basically, this is a practice of handling compressed gas cylinders. So why is there a need to return it when there's still 25 psi? Is it not a basically is it not wasteful to just return it when you know it has contents? So what is the reason behind this one? A, because the trained personnel is used to filling contents without remaining pressure inside the cylinder. B, to prevent atmospheric contamination of the cylinder. C, to avoid explosion or combustion of the cylinder. D, none of the above. So letter A, basically, the trained personnel is true. It is true that it's used to filling contents without remaining pressure. But the question here is, what is the reason behind it? Letter B, to prevent atmospheric contamination of the cylinder. This is a good answer because basically, if you have a pressure contained in that cylinder, the atmospheric gases will not be able to enter it because the pressure of the atmosphere is what? 14.7 psi. So basically, it will not be able to contaminate the contents of the cylinder. So letter C, to avoid explosion or combustion of the cylinder. This might be problematic, but in order for the cylinder to explode, it needs to have a source of heat. So basically, in this example, there's none. Letter D, none of the above. So the answer here is letter B. To prevent atmospheric contamination of the cylinder, the remaining pressure will serve as a seal, preventing the atmospheric gases from entering the cylinder. So the last question for this set is, to prevent fumes during welding, the most important factor is the type of base metal, the type of welding process, C, the type of filler metal, D, the position of the welder's head. So to prevent fumes during welding, so what will be the most important factor? Meaning the most important factor is the one that you can control, basically. So letter A, the type of base metal. Basically, different base metals have different production of fumes. So as letter B, the type of welding process. So different because of different filler metals that is used, different base metals, and the flux that is used for that specific filler metal, and the duty cycle used in the welding machine. So it differs depending upon the welding process. So letter C, the type of filler metal. So as I've mentioned, depending on the composition of that filler metal. Letter D, the position of the welder's head. Now this is the most important factor during to prevent fumes, as for example, during the design of the welder's helmet, the ANSI standard for safety of welding, basically it has a clause wherein you need to conduct samples of the design for the design of the welding helmet near the breathing zone of the welder's head. So that's how important it is, the position of the welder's head. You need to sample that breathing zone to have a baseline in terms of designing the welder's helmet. Yeah, so the answer is letter D. It is the most important factor as this has the most exposure to the fumes, and not only the welder's helmet but also the ventilation, the type of ventilation used for that activity must also be designed to accommodate the position of the welder's head. This element or elements, when present in metal, can produce or cause what they call metal fume fever. A, zinc or copper. B, asbestos. C, fluorine. D, none of the above. So letter B, asbestos, it is now known to be a cancerous substance or a very harmful substance. Basically, before you use it or use it in any type of project or maintenance activity or repair, rehab, basically you need to consult with the local authority for the use of asbestos. Letter C, fluorine, it is one of the elements or compounds used in the coating of the electrode. So the answer here is letter A. So letter A is zinc or copper normally produces fumes that can cause nausea or what they call a metal fume fever. Next question. Which of the following statements regarding oxygen is true? Letter A. Oxygen less than 23.5% creates a fuel-rich environment. Letter B. Oxygen is non-flammable but supports combustion. Letter C. Oxygen below 19.5% can still support life. Letter D. Both A and C. So basically, the CWI exam has this types of questions. The last choice is basically he or it opted. It will opt you to choose between both or two answers for two answers. So let's explain each. So letter A, oxygen less than 23.5% creates a fuel-rich environment. Actually, if it is above 23.5%, it will create a fuel-rich environment. So this is especially important for confined spaces, wherein before you start welding or before the welding activity commences, the safety or the safety personnel needs to check via a gas detector or whatever instrument if the confined space has enough or will not exceed 23.5% threshold for creating a fuel-rich environment. So letter A is not correct. Letter B, oxygen is non-flammable but supports combustion. Yeah, this is a good answer. Basically, oxygen is not flammable by itself, but if you would remember the fire triangle, so basically oxygen is one of the components need to support combustion. So letter C, oxygen below 19.5% can still support life. Actually, the 19.5% is the threshold. If you reach below that, the oxygen level for that confined space or any area will not be able to support life. So the answer here is letter B. Oxygen is non-flammable but supports combustion. Next question. Which of the following statement is false? So letter A, primary shocks cause physiological harm. Basically, this question is regarding electric shock. Letter B, primary shocks are currents greater than 6 milliampere. C, secondary shocks are currents from 0.5 to 6 milliampere. Letter D, secondary shocks can cause death. So which of the following statement is false? So by the way, you can pause at any time if you want to think of the correct answer. So the answer here is letter D. So why are the others incorrect? So primary shocks can indeed cause physiological harm. So these shocks are greater than 6 milliampere. So letter B is also correct. Letter C, secondary shocks are indeed classified from 0.5 to 6 milliamperes. They don't cause physiological harm. They might cause minor tingling of the senses or the muscles, involuntary movements of the muscles, but they will not cause physiological harm or irreversible harm to the organs of the person if exposed to that kind of current. Next question. Acetylene should never be operated above blank PSI. So what PSI is that? A15, B20, C25, D30. The answer here is letter A. So above 15 PSI, the acetylene can become highly unstable and can explode. So acetylene is a highly volatile gas. So if it is operated or pressurized above 15 psi, it can explode the cylinder, so it can cause accidents. So it should never be operated above 15 psi. So you need to also check the manual of the acetylene cylinder before operating it, just to be sure. The last question for this set is, hot spotter can travel up to blank feet. So letter A, 15, B, 20, C, 35, D, 30. So the answer here is, so this is a basic question regarding welding safety. The answer here is 35 feet. So this is the reason why workplace must be free of combustible materials, as this hot spotter is still very flammable and combustible, and it can kickstart a fire if it is in contact with the combustible materials like wood, paper, etc. So if this is not possible, so you have to provide fire blankets, fire coverings, fireproof coverings for the possible combustible materials that can be ignited by hot spotter. A fire watch can also be assigned at site to have a continuous stream of water and basically be on a watch for those hot spotter being spread throughout the workplace.
For the first question, this welding process operates by heating the metal with an electric arc between a covered metal electrode and the metals to be joined, more commonly referred to as stick welding. Letter A, SMAW. Letter B, GTAW. Letter C, GMAW. Letter D, SAW. So for the choices, GTAW is gas tungsten arc welding or TIG welding, so that's not the correct answer. Letter C, GMAW or MIG welding is also not the correct answer because it refers to us as the gas metal arc welding or MIG welding. Letter D is SAW or submerged arc welding. It is a fully automatic process. So the answer here is stick welding is known as SMAW. So as you can see here, the flux coating or the electrode produces a shielding gas that protects the weld pool from harmful atmospheric gases that will embrittle the weld. So that's the basic principle of SMAW. Next question. This is one of the characteristics of the electrode coating in SMAW where it decomposes to form a gaseous shield for the molten metal. Letter A, shielding. Letter B, deoxidation. Letter C, alloying. Letter D, insulating. So for the choices, deoxidation is the process or the characteristics of the electrode that removes the impurities from the molten metal. Alloying refers to as the addition of elements that will improve the mechanical properties of the weld. Insulating is the property of the electrode that produces a solidified slag that will prevent the sudden drop of temperature for the weld, thus preventing embrittlement. So the answer here is letter A, shielding. It is the characteristic of the electrode coating where it decomposes to form a gaseous shield for the molten metal for the purposes of protecting it from harmful gases that will embrittle the weld or cause unattended weld defects. Flux coating improves the electrical characteristics to increase arc stability. What do you call this characteristic of the flux coating of SMAW? Letter A, shielding. Letter B, deoxidation. Letter C, alloying. Letter D, ionizing. So the answer here is letter D. So as I've mentioned in the previous question, shielding is the property or the characteristic of SMAW wherein it prevents harmful gases from entering the molten pool of metal, from contaminating the weld and causing embrittlement. Deoxidation produces chemicals into the weld that will oxidize the molten pool of metal. Alloying, as I've mentioned earlier, also produces the elements that will improve the characteristics of the molten pool of metal and thus improving its mechanical properties. So that leaves to us the letter D as ionizing, which is the correct answer, which is the improvement of the electrical characteristics to increase arc stability. So arc stability is very important during stick welding because it's a manual welding process, because you need to ensure that the creation of arc during the welding process is stable so as not to produce a defect. Next question about welding electrodes. What does the first two digit of this SMAW electrode mean? E7018. A weld diameter of 0.7 mm, tensile strength of 70 MPa, tensile strength of 70 KSI, letter D, low hydrogen electrode. The answer here is letter C. So the first two digits of this SMAW electrode is
the number 70 or 70. So the first two digits, or the first two to three digits of a SMAW electrode is commonly pertaining to the tensile strength of the electrode measured at KSI, or 1,000 pounds per square inch. So that leaves us with the answer of letter C, 70 KSI tensile strength of this SMAW electrode. Next question. Since SMAW is a manual process, the welder must constantly replace the consumed electrode, affecting its blank: A. Current, B. Productivity, C. Maintenance, D. Arc length. So letter A from these choices does not make any sense. So if you replace the consumed electrode, it will not affect the current setting of the welding machine. Letter C, maintenance. So if you replace the consumed electrode, it does not mean you're maintaining the electrode or the welding machine. So it's not the correct answer. Letter D, arc length. So the arc length, meaning the measurement of the weld arc that is produced during the weld. So that's not the correct answer. So that leaves us to letter B, productivity. Because as you replace the consumed electrode, you're basically wasting time replacing that electrode instead of just producing the weld continuously. This is the main problem for SMAW, as it is a time-consuming process because you need to replace the consumed electrode every now and then. So this problem or this issue will be resolved for other processes such as the GMAW or FCAW.
Which of the following methods is most likely to use a transducer to scan for flaws? Letter A, RT, letter B, MT, letter C, UT, letter D, PT, letter E, VT. The NDT method most likely to use a transducer to scan for flaws is UT, or ultrasonic testing. Hence the answer here, letter C. UT makes use of a transducer attached to an electronic base unit. This machine generates precise electronic pulses transmitted through a cable to the transducer. RT is an NDT but makes use of preferential radiation transmission or absorption. Magnetic particle test, or MT, utilizes magnetic field to detect surface and subsurface discontinuities. PT, or penetrant testing, uses the principle of capillary action to detect flaws. VT is visual testing, or visual inspection, where the inspector detects flaws by using his naked eye and some measuring instruments. The answer here is letter C, UT. For plain carbon steels, how are hardness and tensile strength related? Letter A, increase hardness, decrease tensile strength. B, increase hardness, increase tensile strength. C, decrease hardness, increase tensile strength. D, hardness and tensile strength can both be increased by tempering. E, hardness and strength are not related. As hardness increase, tensile strength also increase. Hence, the answer here is letter B. A great approximation of this is the formula of BHN, which is equal to half of the ultimate strength in KSI. This alone can be a great reminder that as hardness increase, the tensile strength also increase. BHN is Brinell hardness number, which measures the resistance of the material against indentation, which is the hardness. Hydrogen in the molten weld metal can cause A, undercut and overlap, B, cracking and porosity, C, incomplete penetration and incomplete fusion, D, porosity and slag inclusions, E, hydrogen will diffuse during welding and will not cause problems. Now this question pertains to welding discontinuities and defects. Let's run through all of the choices. Porosity is normally caused by the presence of contaminants or moisture in the weld zone, which decompose due to heat and form gases. And one of them is hydrogen. Because our atmosphere contains moisture, hydrogen from said decomposition of moisture causes this discontinuity.
Other sources of moisture or hydrogen can be poorly stored electrode, moisture in the base metal, and with the shielding gases as well. Cracks can also be a result of hydrogen entrapment which propagates in the intergranular or transgranular structure of the metal. Letter B is the answer here. Hydrogen in the molten weld metal can cause cracking and porosity. Now let's discuss the other choices, why it is the wrong answers. Undercut is a surface discontinuity which occurs in the base metal directly adjacent to the weld. It is a condition in which the base metal has been melted away during the welding operation and insufficient filler metal deposited to adequately fill the resulting depression. Overlap in the meantime is the protrusion of weld beyond the weld toe or root. It appears though that the weld has overflowed the joint and laying on the adjacent base metal. Incomplete penetration is a discontinuity associated only with groove welds. It is a condition where the weld metal does not extend through the joint thickness. Incomplete fusion in the meantime is a weld discontinuity in which fusion did not occur between weld metal and fusion faces or adjoining weld beads, meaning the weld metal and the base metal did not fuse together. Letter E is obviously not correct because hydrogen is one of the causes of cracking and porosity. The answer here is letter B, cracking and porosity. Which of the following results from improper termination of the SMAW electrode and shrinking of the molten weld pool during welding? Letter A, porosity. Letter B, slag inclusions. Letter C, delayed cracking. Letter D, crater cracking. Letter E, incomplete fusion. Crater cracking occurs at the termination point of individual weld pass. If the technique used by the welder to determine the arc does not provide for complete filling of the molten weld puddle, the result will be a shallow region or a crater. Hence the answer here, letter D, crater cracking. It is a result of improper termination of the welder at the arc which does not provide a complete filling of the molten weld puddle. For the choices, porosity here is the result of moisture or gases in the weld. Slag inclusions normally occur between the weld and base metal, where foreign solids like slag, flux, tungsten, or oxide slips through the weld. Delayed cracking is categorized under cold cracks, which occur after the metal has cooled to ambient temperature. So the cracking occurs after the weld metal has been cooled already. Incomplete fusion is a weld discontinuity in which fusion did not occur between the weld metal and the fusion phases. Entrapped slag can result when using all of the following except letter A, SMAW, letter B, SAW, letter C, FCAW, letter D, ESW, letter E, GMAW. So if you're not familiar with this abbreviation, better start now because it is important in the CWI exam. SMAW is shield metal arc welding, SAW is submerged arc welding, FCAW is flux cored arc welding, ESW is electroslag welding, GMAW is gas metal arc welding. Entrapped slag cannot be a result of GMAW because of the absence of flux. GMAW does not have flux. All of the processes here in the choices have flux in one form or the other. SMAW, FCAW have flux coating and flux core respectively. This flux produces slag. SAW has granulated flux that covers the weld pool. ESW is electroslag welding. There's slag on that process of course. GMAW does not have flux or slag, hence the answer. To prevent atmospheric attack, this process makes use of an external shielding gas like CO2, argon, oxygen, etc. The rapid quenching of a high carbon steel from the austenitizing range will result in the formation of letter A, perlite, letter B, martensite, letter C, cementite, letter D, ferrite, letter E, austenite. Very rapid cooling or quenching takes place when there are significant changes in the transformation of a given steel alloy, and if that steel has high enough carbon, martensite will be formed. Hence the answer here, letter B,
martensite. Martensite exhibits a body-centered tetragonal structure which has high internal energy resulting to high hardness and tensile strength, but comes with low ductility and toughness. For the choices, pearlite forms at a slower cooling rate than bayanite and martensite. Bayanite forms at a slower cooling rate than martensite, hence with lower ductility than pearlite. One characteristic of bayanite is that it is very difficult to see under the microscope. Austenite forms at around 1300 degrees Fahrenheit when pearlite and ferrite began to change to austenite, but not all of them. It is at 1550 degrees Fahrenheit when the transformation of austenite is complete. Cementite is formed at similar temperatures when ferrite and pearlite is formed, but for higher carbon content steels. When an austenitized carbon steel is cooled to room temperature, an increase in the cooling rate will result in letter A, increase in hardness and decrease in ductility. Letter B, an increase in tensile strength and a decrease in hardness. Letter C, a decrease in tensile strength and an increase in hardness. Letter D, an increase in ductility and a decrease in hardness. Letter E, a decrease in hardness and an increase in ductility. As a general rule, when austenite is cooled rapidly, hardness increases and ductility decreases because of the formation of martensite, which exhibits lower toughness. Letter B does not normally happen because hardness normally increases with tensile strength. C is just the opposite of letter B, and letter D is just the opposite of B, and letter E is the direct contrast of the answer. Hence, the answer here is letter A, an increase in hardness and a decrease in ductility. Generally, when an austenitized carbon steel is cooled to room temperature at a higher cooling rate, it becomes more brittle, hence the decrease in ductility and decrease in toughness. The heat treatment in which a carbon steel's temperature is raised to the austenitizing range, held for a prescribed time and then allowed to cool to room temperature while remaining in the furnace is referred to as letter A, stress relief, letter B, annealing, letter C, normalizing, letter D, tempering, letter E, austenitizing. Annealing is the slow cooling of metal to improve its ductility. The slow cooling occurs when this metal is remained at the furnace until it reaches room temperature. Hence, the answer here is letter B, annealing. For the choices, stress relief is the general process of removing residual stress after welding, and the other choices refer to other heat treatment processes aside from austenitizing, which is the process of formation of austenite at different temperatures depending on the material composition. Which of the following is least affected by the surface finish of the specimen? Letter A, tensile strength. Letter B, fatigue strength. Letter C, impact strength. Letter D, Nick break test. Letter E, macro etch. All of the material properties mentioned in the choices are affected by surface finish. Any imperfections in the metal can cause stress concentrations that can affect tensile strength. Surface finish is one of the factors considered in the calculation of endurance strength or fatigue strength. Impact strength is greatly affected by these imperfections because materials are easier to break when there are surface finish issues. Macro etch testing is a test that reveals surface imperfections, and just like any surface and subsurface testing, surface finish has an effect on this testing if not properly done, like surface preparation, etc. Nick break test is a test for determining the quality of the weld. It breaks open the weld lengthwise. Surface finish has nothing to do with the inspection and preparation of this test, hence the answer. Letter D, Nick break test. The heat treatment in which a carbon steel's temperature is raised to the austenitizing range, held for a prescribed time and then allowed to cool to room temperature in still air is referred to as letter A, austenitizing, letter B, normalizing, letter C, annealing, letter D, quenching, letter E, tempering. Normalizing is the cooling of metal from the austenitic range to room temperature in cool air. So for example, in annealing, you cool the material but you leave the furnace open to expose the metal in air.
that is normalizing. Austenitizing is the process of formation of austenite at different temperatures, depending on the material composition. Quenching is the rapid cooling of metal by form of oil or liquid bath, increasing the material's hardness. Annealing is the slow cooling of metal to room temperature, and tempering is increasing the material's toughness after quenching. Hence, the answer here is letter B, normalizing. A written qualified procedure prepared to provide direction for making production welds to code requirements. A. Procedure qualification record. B. Welder performance qualification. Letter C. Welding procedure specification. Or letter D. None of the above. So this question pertains to what is the welding document that is used to provide a direction for the welder in making sound production welds. So what do you call that document? So the answer here is letter C, welding procedure specification. This welding document is like a recipe or a written step-by-step procedure that is used by the welder in making sound production welds. So this is the document that the welding inspector should refer to as well in ensuring that the quality assurance metrics or the quality assurance documents has been followed or is being followed at site, because this has been proven to produce sound welds. Next question. A record of variables recorded during the welding of the test coupon. It also contains the test results of the tested specimen. Recorded variables normally fall within a small range of the actual variables that will be used in production welding. So this question also pertains to the pertinent welding documents that are used at site or is being used for the welders and welding inspectors alike. So letter A, procedure qualification record. B, welder performance qualification. Letter C, welding performance specification. Or letter D, none of the above. So this welding document refers to the record of the variables used during the production of the test coupon, meaning as the welder produces the test coupon, this is where the variables are being recorded, more like a lab report, with the parameters being listed in the test report. So what do you call that document? Now this document is called the procedure qualification record. So this is where you qualify the weld as specified in the welding procedure specification. Meaning to say that the welding procedure specification will not go or should not go without the procedure qualification record, as it is the document proof that the welding procedure specification will produce the sound weld as specified in the written procedure. Next question. This is the record of welder qualification tests and shall include the essential variables, type of test, and the ranges qualified. Letter A, procedure qualification record. Letter B, welder performance qualification. Or letter C, welding procedure specifications. Or D, none of the above. So the answer of course in this question is letter B, welder performance qualification. So this welder performance qualification is an important welding document that specifies the range of variables that the welder is qualified in accordance with the applicable codes and standards. For example, the welder is qualified with ASME 9, so the essential variables specified for that process is included in this document. Also, the range of the variables qualified and the tests that the welder has done to prove that he is qualified for that welding process. So remember that the welder is being qualified for a specific welding process, not a specific procedure. Because if you qualify the welder for a specific procedure, you can just imagine thousands and thousands of documentation will be needed for that welder to be qualified for that specific procedure. So next question. These variables, if changed, will be considered to affect the mechanical properties of the weldment and therefore shall require requalification of the WPS. So what do you call this variable?
Letter A, essential variables. Letter B, supplementary essential variables. Letter C, non-essential variables. Letter D, none of the above. So the answer here is if the variables will affect the mechanical properties of the weld and base metal, so it is called the essential variable. So examples of these essential variables are the base metal, the filler metal, the type of preheat and post-heat, and the chemical composition of the weld metal. So those are some of the examples of essential variables. So some of it varies slightly in accordance some of it varies slightly according to the specific welding process that is being specified in the code or in the standard. So if these variables are changed, it will require requalification of the WPS. So you will need a new PQR for if you changed the one of the essential variables. So this is the reason why some of the welding procedure specifications have multiple PQRs, because maybe the essential variables have been changed in one of those revisions. Then you have to support that WPS with another qualification. So another thing to remember here is that essential variables is a must, or you need to address it in the document for it to be able, if you're, for example, you'll need to have the WPS reviewed by the client or by another entity. So you need those essential variables to be addressed properly, so as to prevent the back and forth review of those documents between the other entity or the client you are serving. Next question. This is required for metals for which the referencing code or standard requires toughness test in addition to the essential variables for each welding process. So what do you call this essential variable or this variable? Letter A, essential variables. Letter B, supplementary essential variables. Letter C, non-essential variables. Letter D, none of the above. So if you need toughness test, impact, such as IZOD, sharpen, those kinds of tests, so you'll need to address the supplementary essential variables, letter B. So these supplementary essential variables will become essential if toughness tests are required. For example, if you are looking into codes such as ASME B31.3, API 1104, or ASME 9, or depending on what construction codes you are in. So if toughness tests are required, or if the ductile to brittle transition temperature of the metal has been reached, you need to address the supplementary essential variables. So these are the base metal thickness, the heat input, the current polarity, even the size of the filler metal or the electrode will be an essential variable for some welding process if toughness tests are required. So meaning if impact test or toughness tests are required, automatically these supplementary variables will become essential. So you have to address that in the WPS. Next question. These variables, if changed as described in the specific variables, may be made in the WPS without requalification. So these variables can be changed without requalification. So what do you call that? So A, essential variables. B, supplementary essential variables. C, non-essential variables. D, none of the above. So the answer here is non-essential variables, letter C. So if these variables are changed in the WPS, such as the size of the electrode, the welding technique, some others, depending on the process. So if that is changed, you will not need to requalify the WPS, but you still need to address them in the WPS. So maybe you have a specific orifice cap for the TIG welding you're using. So if you somewhat change it, or down the line your welder change it, so it's okay, you don't need to requalify them, but you still need to address that in the WPS. Next question. Which code gives pre-qualified status to certain weld joint configurations? Letter A, API 1104. Letter B, AWS-D 1.1. Letter C, AWS-B 2.1. Letter D, ASME 9. So the code that gives pre-qualified status to weld joint configuration is letter B, AWS D11. Actually, the structural code for others such as D16 among those are among the AWS list have pre-qualified joint configuration, or they pre-qualify the WPS, meaning you don't need a test coupon to qualify the welding procedure specification as long as the limits listed in those codes and standards are not being exceeded. So if you exceed that, you'll need to qualify those. And some of the processes specified in the pre-qualified status are also specified in order for the welding procedure specification to be pre-qualified. So sometimes, for example, in D11, some welding process are not pre-qualified. For example, GMAW short circuiting or GMAW short circuiting. You cannot pre-qualify that. You'll need a test coupon to, or you'll need a PQR to determine if that welding procedure will be accepted. Next question, how does a welder become certified? So letter A, certification can only be done or can only be obtained by taking a weld test given by a CWI, graduating from a weld school, having documented proof of 5 years in welding industry, or letter D, documenting successful completion of a weld test according to the requirements of an applicable standard. So depending on what code you are in, so the qualification of the welder differs, but the most common is that as I've said, depending on the code or standard. So the answer here is letter D. So the welder can become certified for example with ASME 9 or AWS D11 if he qualifies for the weld test that is being specified in the standard or in the code. So for example, they have different qualification tests that will be needed. If the welder passed those tests, then he will become a certified welder for that specific standard or for the process or for the specific welding process of that standard. Next question. AWS D11 has a pre-qualified list of welding processes. Which of the following is not a pre-qualified process? Letter A, SMAW or stick, B, GTAW or TIG, C, GMAW, short circuiting, S is for short circuiting, or letter D, FCAW. So I think I preempted this question a while ago. So the answer here is letter C, GMAW short circuiting. So this gas metal arc welding short circuiting is not a pre-qualified process because the current and voltage setting for this process is very low. The heat input is very low, that the chance of having a discontinuity in the weld is very high. So the code, the AWS D11 code specified it as you need to qualify it with a procedure qualification record, or you have to test a coupon in order for the welding process to be qualified. So if you don't have that proof or test document proof, this welding document or this welding process will not be qualified. Which of the following is not a valid qualification of the weld procedure? Letter A, pre-qualification. Letter B, welding test coupons. Letter C, mock-up tests. Letter D, writing a procedure only. So if we're gonna run through the choices, so pre-qualification is a valid qualification of the weld procedure depending on the code. So AWS D11 specifies a pre-qualification of a welding process if the limits of the parameters are not being exceeded. So letter B, welding test coupon, is also a valid qualification of the weld procedure. Letter C, mock-up tests. So if there are constraints at site that needed a mock-up, it will be tested. It will be tested in accordance with the actual site conditions, because maybe the welding position is too tight, the clearances, etc. So you need a mock-up for that. Even though the code or standard does not require mock-up tests, so if the employer or the owner requires it, so you will need a mock-up test specified in the procedure qualification. So that is a valid qualification of the weld procedure. So letter D, writing a procedure only. So depending on the code or standard, if you write a procedure only without qualification tests, so the keyword here is only, so that is not a valid qualification of the welding procedure. So just a tip, if you are answering for a certification exam, if those over-encompassing statements like only, all, maybe that denotes maybe a wrong answer for the certification exam. So similar to that situation, this statement that is indicating only is the wrong answer. So meaning this is not included in the qualification of the weld procedure. So the answer here is letter D, writing a procedure only. So you'll need the three choices above, pre-qualification or welding test coupons or the mock-up tests, in order to qualify a weld procedure.
Dwell time is a term associated with which NDE method? Letter A, MT, letter B, PT, letter C, RT, letter D, ET, letter E, UT. Dwell time is closely associated with penetrant testing. Dwell time, by definition, is the total time that the penetrant or emulsifier is in contact with the test surface, including the time required for application and the drain time. This is not applicable for any other tests mentioned in the choices. Hence, the answer here is letter B, PT. The material property expressed in terms of an endurance limit is letter A, fatigue strength, letter B, toughness, letter C, tensile strength, letter D, ductility, letter E, hardness. The property that is expressed in terms of endurance limit is the fatigue strength. For the mechanical engineers out there, if you can remember the Goodman and Soderberg equation, the endurance limit of the material is synonymous with the fatigue strength. Looking at the other choices, toughness is the resistance of a material against impact, tensile strength is the capacity of the material against a given load, ductility is the property of material to yield against a load without breaking, and finally, hardness is the resistance of a material against indentation. Hence, the answer here is letter A, fatigue strength. The welding inspector is usually not responsible for which of the following? Letter A, checking for proper electrode storage. Letter B, verification of a welder's qualification. C, witnessing all repairs. D, in re-inspecting repairs. E, checking fit-up. Welding inspector is usually not responsible for witnessing every repairs, but is responsible for checking if the repair is satisfactory. Many standards such as API 1104 specifies acceptance criteria for weld repairs, and as such, the welding inspector needs to witness and inspect them. Checking for proper electrode storage is essential since these electrodes have a manufacturer-prescribed storage parameters that is needed to be followed, such as storage temperature to eliminate moisture. Moisture in the electrode can cause porosity. Verification of welder's qualification and creation of WPQR or welder qualification record is a responsibility of a welding inspector, as he should determine whether a welder passed a certain code such as ASME 9, AWSD 11. Letter D is what I mentioned regarding reinspection of repairs, wherein the inspector must check if the weld repair has satisfactory results. Checking fit-up prior starting a root pass is a common hold point that the inspector usually does to accomplish the inspection and test plan. Hence, the answer here is letter C, witnessing all repairs. It is not common for the welding inspector to be responsible for witnessing all the repairs done. The last digit of a SMAW electrode designation is an indication of A, tensile strength of the weld deposit, B, position of the welder to qualify the weld-in, C, operating characteristics, D, impact strength of the weld deposit, E, position suitable for electrode use. The last digit of a SMAW electrode denotes the operating characteristics of an electrode. It denotes the type of current, the arc characteristics and penetration, the type of covering and slag, and percentage of iron powder used.
It also denotes if the electrode is low hydrogen type or not. Ending with 5, 6, and 8 denotes low hydrogen electrodes. Hence, the answer here is letter C, operating characteristics. For SMAW electrode designation E60X3, the X refers to A. Tensile strength of the weld deposit, B. Position in which the electrode can be used, C. Type of coating, D. Recommended type of current, E. Flux chemistry. In this question, the X denotes the position in which the electrode can be used. The position in which these electrodes can be used also depends on its operating characteristics. High deposition electrode cannot be done on an overhead position, since a lot of molten metal will fall to the welder, and this is denoted by digit 2. 1 denotes that the electrode can be used for all position. Digit 3 is no longer used as a designation, so if you see that, it is an old designation. 4 denotes welding in a downhill progression. Here, hence, the answer here is letter B. The X here denotes the position in which the welding electrode can be used. In SMAW, an increase in arc length results in letter A, increased current, increased voltage. Letter B, decreased current, increased voltage. Letter C, increased heat input, decreased voltage. Letter D, decreased current, decreased voltage. Letter E, decreased current, increased heat input. This question can be best explained with a graph. As a welder increases its arc length, the resistance in the welding circuit also increases because of the larger gap between the electrode and the base metal. As seen here in the voltage current graph of SMAW, the increase in resistance caused a slight decrease in the current flow across the gap, in this case 10%. This decrease results in a significant increase in voltage, in this example 32% supplied by the power source, which limits the drop in current. So, from the choices below, the answer is letter B. Decreased current, increased voltage. Next question. Weld inspection report should always letter A, be completed in ink or typewritten and signed. Letter B, be done in pencil so mistakes can be erased. Letter C, be filled out only if the weld is rejected. Letter D, retyped by a clerk so that everything is readable. Letter E, include the welder's identification. Letter B is not advisable since temporary written reports are prone to ineligibility later on. Weld report is done whether the weld is accepted or rejected, so letter C is not the answer. The weld inspection report shall be done by the one who inspected the weld, preferably the one in charge of the welding quality control program or a CWI. It can be retyped by a clerk but is not necessary. Since the question specifies always, this is not always the case. The weld inspection report does not necessarily indicate the welder's identification. The report may contain the welder ID but not always needed. The answer here is letter A, be completed in ink or typewritten and signed. The weld inspection report must be completed in ink, must be written clearly and illegibly, and must be signed by the one who created the report. Next question. The ability to be cyclically loaded without failing is related to which of the following properties of a metal? Letter A, hardness. Letter B, toughness. Letter C, tensile strength. Letter D, fatigue strength. Letter E, ductility. Hardness is the resistance of a material against deformation. Toughness is the ability of the material to absorb energy without fracture and can be measured through impact testing. Tensile strength is the maximum load a material can withstand before fracture. This is before the end of the stress strain curve as seen. Ductility is synonymous to toughness. It is the ability of a material to deform plastically in tension or shear without fracture. This leaves us to the answer, fatigue strength, which pertains to the resistance of a body against cyclic forces. Fatigue strength is the resistance of a material against the cyclical forces that normally occurs throughout the life cycle of a metal or a material. Next question. Which of the following is truly a volumetric test method? Letter A, RT. letter B, UT, letter C, VT, letter D, MT, letter E, PT. RT is a type of volumetric test but with limitations. RT pertains to radiographic testing. VT, pertaining to visual testing, is limited to surface only, while PT, penetrant test, and MT, magnetic particle test, can detect surface and subsurface discontinuities. UT is truly a volumetric test because it can do RT's limitation, which leaves us to the answer here, letter B, ultrasonic testing. Ultrasonic testing is much more versatile in comparison with RT, which has its limitation depending on the location of the radiographic source. Next question. Use of preheat will result in a faster cooling rate and wider heat affected zone, a faster cooling rate and narrower heat affected zone, a slower cooling rate and wider heat affected zone, a slower cooling rate and narrower heat affected zone. Preheat helps prevent quick cooling of metals and promotes finer grain structure and helps against embrittlement. By this definition, the best answer that fits this description is letter C. It will result in slower cooling rate and wider heat affected zone since greater heat input is present in the base metal due to the preheating. The material property that best describes its ability to withstand the load is letter A, hardness, letter B, toughness, letter C, tensile strength, letter D, fatigue strength, letter E, torsional strength. The ability to withstand a static load is letter C, tensile strength. Strength is defined as the load induced on a specified area. Let's take a look at the choices. Hardness is the resistance of a material against deformation or indentation. Toughness is the ability of the material to absorb energy without fracture and can be measured through impact testing. Fatigue strength is the resistance against cyclical loads, and torsional strength is the resistance against twisting loads and moments. Next question. The welding variables used to calculate heat input are letter A, voltage and current, letter B, current and travel speed, letter C, voltage, current, and travel speed, letter D, travel speed, preheat temperature, and voltage, letter E, voltage, current, and preheat temperature. Voltage, current, and travel speed affects the heat input, which is the answer here, letter C. Voltage is the amount of electricity induced in the base metal. The current, similar to voltage, increases the heat input as the amount of electricity increases. If we remember, heat input is a function of energy per unit time, which the formula of power is voltage times current. The travel speed is measured by the length of the weld deposited in an amount of time. The faster the travel speed, the lesser heat input is produced, while a slower travel speed, meaning the electrode is almost staying at one point in the base metal, then the heat input will be higher. Preheat temperature does not have anything to do with heat input but will have something to do with the grain structure of the material, which then affects the material's hardness and weldability. Next question. In general, an increase in the carbon equivalent of a carbon steel will result in an increase in its letter A, ductility, letter B, hardness, letter C, defects, letter D, toughness, letter E, all of the above. An increase in carbon will increase hardness, which is the answer here, letter B. Similarly, an increase in carbon also increases the tensile strength. Hardness and ductility is somehow works opposite to each other, so that's the answer. Defects do not have anything to do with this and is caused by several factors such as workmanship, poor preparation, poor heat treatment, etc. Toughness is the ability of the material to absorb energy without fracture and can be measured through impact testing, which leaves us to the answer here, letter B. As the temperature of the base metal is increased, letter A, impact strength decreases, letter B, tensile strength decreases, letter C, ductility decreases, letter D, hardness increases, letter E, tensile strength increases. When the temperature of the base metal is increased,
the tensile strength decreases, which is the answer here, letter B. This decrease is apparent if you see some construction codes like ASME B31.3. You can see that the strength decreases if the metal is subjected to higher temperatures. These metals tend to become softer, so to speak, because of the increased molecular activity due to the higher energy input, which is the consequence of higher temperature. For the choices, impact strength decreases on colder temperatures, not high. That is why you need impact testing when welding at frigid temperatures. Decrease in ductility is synonymous with a decrease in impact strength. Hardness and tensile strength increase is the direct opposite of the answer, as hardness and tensile strength is almost synonymous to each other. Knowing the effects of temperature to the base metal is an essential knowledge base in the Part A of the CWI exam, so you need to know this. Next question. A weld inspection plan should be developed A. Before welding begins, B. During welding, C. After welding is completed, D. Before shipping the work, letter E. Only when there's a problem. A weld inspection plan should be developed before the welding begins, which is the answer. Similar to an inspection test plan, which must be approved prior to the actual inspection activity. This inspection plan also defines the hold points in which the welding inspector will inspect the result of an activity. For example, the root pass will not be able to proceed to the next activity if and only if it yielded a positive result. These hold points will be difficult to implement if these inspection plans are done anytime after the welding activity begins. Which of the following represents the proper eye protection for SAW? Letter A. Welding helmet with filter lens of the appropriate shade. B. Clear safety glasses. C. No eye protection is required because there is no visible arc. D. Tinted safety glasses. Or letter E. A full face shield with a shade number 5 minimum. So unlike the other welding processes, submerged arc welding process has a high operator appeal because of the lack of a visible arc, which allows the welding operator to control the welding without the need for a filter lens and other heavy protective clothing. Since the flux covers the molten pool of metal, the arc is not visible and lesser smoke is generated, unlike other welding processes. But with this, you still need to protect your eyes because of the flux, but no specific tint protection is needed. Hence, the answer here is letter D. In this question, you need to be familiar of two aspects of welding inspection: safety and the welding process itself. Next question. An E7018 SMAW electrode exhibits which of the following characteristics? Letter A. Low hydrogen used on AC only iron powder. Letter B. Low hydrogen used on AC and DCEN. Letter C. Low hydrogen AC and DCEP iron powder. Letter D. Rutile DCEP. Letter E. Rutile DCEP iron powder. I have a video regarding this SMAW electrode classification, which you can click here if you need more information. E7018 is a low hydrogen electrode, so by process of elimination, letter D and E can be ruled out. Normally because the electrode which ends with the digit 5, 6, or 8 can be concluded that as a low hydrogen electrode. This leaves us to the familiarity of this table below as seen. The digit 8 can be used for AC and DCEP with 25 to 45% iron powder. That leaves us with letter C, which is the answer. Low hydrogen can be used with alternating current and DC electrode positive and with the use of iron powder. A thermal treatment that follows quenching and restores some of the metal's ductility is referred to as A. Stress relief, B. Tempering, C. Hardening, D. Normalizing, E. Post-heat. Let us run through the choices. Stress relief is a general heat treatment term that removes residual stresses of the metal. So this stress relief term can be mechanical or thermal, so it doesn't specify here. Normalizing is the heat treatment process where the metal is cooled in still air, which results in a middle range of being a ductile and brittle material. Hardening here in the meantime is synonymous with quenching because if the metal is subject to quick cooling in order to create
for example, tool steels, which are very hard metals and are used for fabrication equipment like milling machine, lathe machine, etc. Post-heat is a term used to relieve residual stress of the metal and is applied after the welding process, and normally is a thermal process. Which leaves us to the answer, which is letter B. Tempering restores some of the material's ductility, which follows after quenching. Since quenching's intention is to rapidly cool the metal to make it harder, it will lose some of its ductility. Tempering attempts to restore some of that metal's ductility to an acceptable range, depending upon the welding procedure specifications. Next question. Which of these methods is most often used to eliminate the high residual stress by welding? Letter A, pre-bending. Letter B, shot blasting. C, quenching rapidly after welding. D, post-weld heat treating. E, preheating. So pre-bending here refers to the parts before welding to counteract shrinkage by introducing pre-stressing. So when you pre-stress a part before welding, you counteract the shrinkage that will be caused by welding. So this term is called pre-bending. So it does not fit the description of the question, which eliminate the high residual stress. Shot blasting, in the meantime, is a form of surface preparation technique used to remove debris and irregularities in the base metal. So some examples here is sandblasting. So when you prepare a metal prior welding or prior painting, so you sometimes you need to sandblast it in order to remove the irregularities or debris or an external coating that is undesirable prior to welding or repainting of that base metal. Quenching rapidly after welding will result in the formation of martensite, which a grain structure that promotes brittleness. So it does not relieve the stresses in the weld, but rather promote the formation of a grain structure that promotes brittleness. So letter C is not the answer, although quenching is a form of heat treatment as well, but it does not or it promotes brittleness of the metal. Preheating promotes appropriate grain structure by preventing rapid cooling of the metal, but the trick here or the question here is it eliminates high residual stress by welding, which only meant that the stress is produced after welding. So this leaves us with the answer letter D, post-weld heat treating, which the primary purpose is to eliminate residual stress due to the welding. Next question. The physical principle that permits the migration of liquid penetrant into very fine surface discontinuities is called magnetic permeability, B, optical fluorescence, C, capillary action, D, emulsification, E, solubility. So there's only one answer here that refers to that physical principle, which is letter C. Now, this concept is the basis of dye penetrant testing, wherein after the penetrant went into the pores or crevices of the weld, and after applying the developer, it reveals whatever discontinuity the weld might have. This is by the concept of capillary action, where the liquid ascends through a slim or permeable substance. The answer here is letter C. All other choices refers to other chemical analysis like the magnetic permeability, optical fluorescence, and letter D and E refers to a chemical process wherein emulsification and solubility refers to another or other chemical processes that not involve welding. When a metal is alloyed, how are the atoms of the alloy incorporated into the original metal lattice structure? A, by inclusion or exclusion. B, by becoming martensitic. C, substitutionally or interstitially. Or D, by casting. So letter A, inclusion or exclusion, is not a term for incorporation of these atoms in the original lattice structure. Letter B, by becoming martensitic, is that it is a form of a heat treatment that when a metal is being rapidly cooled, it forms a martensite that produces a structure that will tend the material to become brittle. Letter B, by casting, is a form of
manufacturing process that enables the metal to be formed into a certain shape. So the answer here is letter C, substitutionally or interstitially. So when alloying a metal, the properties of metallic elements can be altered by the addition of other elements. So this process is called alloying. So note that when you add an atom into the original metal lattice structure, that is called interstitial or interstitial alloying, because the new atoms will be incorporated into the original lattice structure of the metal. When you say substitution, you replace the original atoms in the original lattice structure. So the answer here is letter C. In general, which of the following is not commonly used as a semi-automatic process? A. GMAW, B. FCAW, C. SAW, D. SMAW. So letter A, B, and C use an automatic process of feeding the filler metal or the wire into the gun of the welding machine. So that goes for MIG welding, for GMAW, for FCAW that goes as well. And of course, SAW can be an automatic process because of the automatic feeding of the electrode or the wire into the gun or into the welding machine. It also has an automatic feeding of the flux so as to prevent the atmospheric attack of the hydrogen and other moisture from the gases surrounding the weld. So out of those processes, the only process here that is not a semi-automatic process is SMAW, because you will have to manually feed the electrode or the welding rod into the machine or into the gun in order for you to proceed with the welding process. Next question. During tempering, as the temperature increases, which of the following statement is correct? A. Hardness increases. B. Hardness decreases. C. Strength increases. D. Elongation decreases. So when tempering, you reduce the hardness of the metal by applying heat into it after quenching. So after quenching of the metal, you will have to increase its temperature slightly to reduce the hardness so as the resulting metal not to be as brittle as it should be if it would be quenched. So the answer here is letter B. So of course, the hardness will not increase if the temperature increases, because hardness increase will normally happen if the rapid cooling of the metal occurs, and that goes with strength also, because of the strength of the metal and its hardness is almost synonymous with each other, because of if the strength of the material increase, that goes with hardness as well. So letter D is false, because the elongation will not decrease, because if the temperature increases, the thermal expansion of the metal will also increase, so the elongation will not decrease if the temperature increases. So the answer here is letter B. Next question. Of the following, which is not a type of metal transfer in GMAW? A. Spray, B. Short circuiting, C. Globular, D. Open circuiting. So for spray, we have two types, pulse spray and conventional. Short circuiting is the lowest heat input amongst all the modes of metal transfer for GMAW. C. Globular, which offers the droplets, or which features the droplets of the metal transfer for GMAW. And that leaves us with the open circuiting, which is not the type of metal transfer in GMAW. Next question. Of the following tests, which can be used for the actual determination of a material's toughness? A. Charpy, B. Magnetic particle test, C. Tensile test, D. Bend test. So what you need to remember here is the test for toughness of a material should be impact. Impact tests normally look for the material's toughness of the metal. So out of these choices, magnetic particle reveals the discontinuity of the welded metal, so that's not the answer. Tensile test reveals the strength of the base metal or the weld metal depending on the test you conducted it to. Bend test actually reveals the soundness of the weld depending on the code or standard you are following. So the answer here is letter A, Charpy. So Charpy is a type of impact test where you produce a notch on the metal, basically you produce a intended discontinuity on the metal, and then you can measure its toughness after you conduct this impact test. Which GMAW metal transfer mode results in the least amount of penetration? A. Globular, B. Short-circuiting, C. Pulse spray, D. None of the above. Globular transfer occurs at a lower voltage and current but at higher levels than short-circuiting. This enables deeper penetration due to the amount of current and heat input. Pulse spray or pulse transfer varies the current during the process, which enables all-position welding because of more control over the weld. It can also be used for thinner metals, which cannot be applicable for globular or the conventional spray transfer, which leaves us to the answer here, short-circuiting. Short-circuiting has the lowest heat input out of all the GMAW modes of transfer because of its low voltage and current setting. Next question. The melting point of carbon steel is approximately A. 2250 degrees Fahrenheit, B. 2375 degrees Fahrenheit, C. 2780 degrees Fahrenheit, or D. 3000 degrees Fahrenheit. If you would look at the iron-carbon phase diagram, the temperature in which carbon steel turns into molten liquid is approximately 2800 degrees Fahrenheit, where you can see the line between the ferrite and the liquid. That means the temperature above it will melt the carbon steel. Carbon steel falls around the 0 to 0.8% carbon. Anything above 0.8% will become a high tensile carbon steel, and anything above 2% will result into cast iron. As you can see here, the melting point of carbon steel is at a higher temperature, which is around 2800 degrees. So the answer here is letter C, 2780 degrees Fahrenheit. Which of the following gases is commonly used as a shielding gas for GTAW or gas tungsten arc welding or TIG? A. Argon, B. Carbon dioxide, C. Oxygen, D. Argon CO2. Argon is the most common shielding gas because not only amongst the choices that it is the only inert gas, but it is also the cheapest among all the shielding gases. Hence, it is the most commonly used shielding gas. The answer here is letter A. Shielding gas can also be used as a mixture. That is why you see the argon CO2 as a choice here. These mixtures of shielding gas will produce a different purpose than when used singularly. ASME Section 2 Part C not only provides information about the filler metals and electrodes, but for the shielding gases as well. The technique which does not aid in reducing residual stress is A. Pinning, B. Vibratory stress relief, C. External restraint, or D. Preheating. Pinning is a form of mechanical heat treatment in the form of hammer blows. So if it is a heat treatment, then can bet that this process relieve residual stress from the metal. So if it is mechanical or thermal heat treatment, then those heat treatment processes can relieve residual stress. So there are forms of heat treatment that can be by mechanical means. So pinning is one of them. Vibratory stress relief is also a kind of mechanical heat treatment that is used to reduce residual stresses. Preheating is a form of thermal heat treatment that enables the material to resist rapid cooling. Hence, it helps prevent distortion and helps in relieving residual stresses, which leaves with the answer letter C, external restraint. External restraint does not have anything to do in reducing residual stresses and may help distort it because metals, when heated, tends to expand. Having external restraints will just add undue thermal stresses on the metal. Next question. Which of the factors listed below has the least amount of effect on the residual stress and distortion that results from welding? A. Heat input, B. Tensile strength, C. Welding position, D. Phase change. Heat input, of course, has an effect on the residual stress because it affects the rate of cooling of the metal. Because when the rate of cooling becomes faster, the more brittle the material gets. Hence, the residual stresses will become greater, or the distortion on that metal will become more prevalent. Tensile strength not only denotes strength but also the hardness of the material. The higher the tensile strength, hence more carbon, the more stringent post-weld heat treatment procedure will be used to remove the residual stresses. SMAW 1
provides a guide in the post-weld heat treatment variables that will be needed to be taken into account, like the amount of equivalent carbon and the thickness of the base metal. So if it has more carbon with the metals with high tensile strength, then the more stringent post-weld heat treatment procedures will become or will have to be implemented. Phase change refers to the change of the property of the metal, and when this happens, you can guarantee that distortion and residual stress already has affected the metal. So that leaves us with the answer here. Letter C. Welding position, on the other hand, does not directly affect the heat input because no matter what the position is, the heat input parameters like current, polarity, and voltage must be followed in accordance with the welding procedure specifications.
If you have questions, do not forget to comment down below and also like this video, as it will help the algorithm find like-minded viewers like you who are looking guides for the CWI exam. And if you want more of these kinds of videos, I have tutorials on CWI practice questions, writing welding documents, and many more. Click these playlists right here. Do not forget to subscribe and turn in the notification bell for the latest videos. See you on the next one.